Welcome to the Betterment Lectures. My name is Dr. Doreen Miners, and if there's one thing I've learned as a brain scientist, it's that there's no instruction manual for this device in our head. But there are patterns of thought, patterns of feeling, patterns of action, because that's what brains are supposed to do, create the patterns that gracefully handle the predictable shapes of everyday life. So let me teach you about them. One pattern, one podcast, and you see if it works for you. Now, as a brain scientist, people often level questions at me about how worried we should be about the rise of AI. You know, AIs are sort of like these brain-like things, and I study brains, so sometimes people think I have ideas. And I should be clear, although I've spent a lot of time with both real and digital neural networks, and I'm taking on a role at Sandhurst, sort of thinking about how we implement AI here at the Military Academy, I'm not really a technical AI person, but I do have some ideas, and maybe the most valid ones are on the subject of AI consciousness, and in particular, why I'm not hugely worried that AI is going to kill us all. So that is essentially what I want to talk about today, trying to convince you that AI isn't really all that scary. So let's get into it. There's a lot online about how worried we should be that AI is going to kill us all. So what I want to point out is that we have been worried about this not since large language models, but even before that. You think of Tristan Harris and the social dilemma, this fear and concern that people have had since the early 2010s about algorithmic production of content, or curation, I should say, of content. We're really worried about AI and how it might end up being at odds with humans. There's an entire domain of research called alignment research that tries to study how we get AI to play nicely with humans into the future. I think there are a lot of ways that AI could really perturb the way that humans work and live, but I'm much more skeptical of the idea that AI is going to destroy us. You know, I think it's pretty natural, or it seems like it's pretty natural for people to assume that AI will get smart and then try and kill us off in this sort of Malthusian competition for resources. There's a video by the same people who produced The Social Dilemma, and they flash up at the beginning that 50% of AI researchers believe that there's a 50% or greater chance that humans go extinct from our ability to control AI. But I really do think that this is an example of what I like to call a psychic predator. News or media phenomena that populate our media streams that we can't do anything about, but feed on our attention, and because we can't do anything about them, grow increasingly stressful. And that is really what I want to talk about today, is one of these psychic predators, which is the idea that AI is going to kill us all. I don't really think that that is one of the risks we need to be worried about. And since you can't do much to change it anyway, I suggest you listen to me instead. So let me see if I can convince you. It seems pretty natural for people to assume that AI is going to get smart. And when it gets smart, it's going to try and kill us. And as the quote that I used earlier sort of indicates, a lot of AI researchers are really worried about the chance of this. But the difficulty is that kind of speculation is a true unknown. We don't know of anything like this happening before, a different conscious species coming in contact with us. So I'm not sure whether we want to take the perspective of AI researchers on this. Certainly, I think that it's reasonable to take the perspective of consciousness researchers on this. And when people are talking about intelligence, whether artificial or not, what we're really talking about is not intelligence in the form of dumb algorithms. We're talking about something closer to sentience, some kind of conscious awareness, a capacity for subjective experience. And the only real model we have for that is a human experience. So We have this intuition that an AI will have an awareness that is basically a human awareness. And we see humans going around killing off other humans and animals that threaten their resources. So when AI gets smart, maybe AI is going to go around and kill us like we do to each other. It'll have this instinct that it needs to kill off the things that are competing with it. And this just seems utterly unlikely to me. And it seems utterly unlikely to me because of the way that I assume that consciousness comes about. Now, there are a few perspectives on consciousness, and this is something I've written and lectured pretty extensively on, so I'll send you away for a more detailed treatment. You can either believe that consciousness comes from something non-material, right? That consciousness might be some part of a soul or a spirit that inhabits a material body rather than something that is entirely one with a body. And importantly, if that's a view of consciousness that you have, I'm not sure necessarily that you're going to agree with me. I don't really have good intuitions about what makes a non-material consciousness happen. But if you don't believe that consciousness is non-material, if you believe that it's a material consciousness, one that depends on the world it lives in, on the body that it arises in, on the way in which our brain connects the inputs from the world to our actions in response, I think you can have intuitions about an AI consciousness. And I don't think that those intuitions take us into Malthusian competition. I think that if you believe that our consciousness depends on the brain in which it seems to inhabit, then an AI consciousness is actually a much more alien, interesting, and probably benign thing than a human one. Let me see if I can talk you through how. So, if consciousness is something that arises from the way that our mind processes the world, then what's important is the processing itself, the information that comes into the mind, our perceptions, and the relevance of that information, the relevance of those perceptions for action. What's interesting about this is we don't really experience stuff that isn't relevant for action. My favorite example of this is how we see color. Humans are trichromats. Our eyes have 3 kinds of photoreceptor. We have 3 colors of channels. So in a certain sense, there are 3 dimensions to our colors. We can see light on wavelengths that correspond to red, green, and blue. In contrast, some birds are tetrachromats. They have 4 dimensions to their color vision. So they can see, for example, ultraviolet light, which is something we can't see. And this isn't like seeing a color you've never seen before. This is more like adding another dimension to color, 4 dimensions versus 3. So to approximate it, imagine that you see not just pink, but slow pink and fast pink, something like this. Now, the reason that we can't see slow and fast pink, the reason we can't see ultraviolet overlaying our colors is because ultraviolet hasn't really been relevant enough to us to perceive it. We don't have an input into the system that codes for ultraviolet light because the human body is only sensitive to stuff that really matters to us. And if you want to be reductionist about it, what really matters to humans, what really matters to living organisms is staying alive. The neuroscientist Kevin Mitchell has this fantastic book about this, and I'll see if I can link to it, but I'll also find a nice YouTube video on this where he talks about it. And to quote him, living things have a prime directive to stay alive. They persist through time in exactly the way a static entity like a rock doesn't, by being in constant flux. Because living organisms aren't just static patterns of stuff, they are patterns of processes. Organisms, even simple ones like bacteria, have goals of getting food in order to support this overarching purpose of persisting. Thus, relative to this goal, we must develop systems that detect food in the environment and mediate motion towards it. He goes on in this vein a little bit, but I think you understand what I'm trying to say. The human body is designed around this purpose, this fundamental property of surviving, of persisting, of reproducing, right? That evolutionary neo-Darwinist imperative. That is what a natural intelligence, like a human intelligence, is organized around. And if you're a materialist, that is what a natural intelligence's consciousness would be organized around, persisting, staying alive. And that is quite a different imperative than an artificial intelligence whose purpose is fundamentally different. I mean, that's why it's artificial. It's not natural. It's not subject to the same kinds of natural selection processes that humans are. And so why would its consciousness be organized around those things? And I want to try and give you an example of what happens when you use the same perceptions that we have, humans have, but we use them for a different purpose. And I want to do this by telling you about the game GeoGuessr. So the game GeoGuessr is this game where you go into a Google Street View of some location, and the point of the game is to try and figure out where you are in the world just based on the Google Street View. And to do this, the really good GeoGuessrs talk a lot about these things they call metas. And metas are things that help identify where you are in the world. So a light pole meta. Certain parts of the world, certain parts of countries will have different light poles. Or trees are another example of a meta. If you see a certain kind of tree, it means that you're in a part of the world that has that kind of tree and not in a part of the world that doesn't. A meta in geoguessing is just a category of fact that's correlated with certain locations. So knowing the light pole meta means that, you're dropped into a Google Street View and you go, oh, this is a Swiss light pole and not a German light pole. And you get a little bit closer to solving the game. Now, the purpose of geoguessing is not to stay alive. The purpose of geoguessing is to most quickly and most accurately work out where you are in the world based on a Google Street View image. And what that means is you start to use your perceptions differently. And there's this guy who talks about the spare tire meta, which is used to work out whether you're in Mongolia or not. So I'll link an image of this, but essentially you get this sort of weird splotch in an image where the camera on the Google car catches a little bit of the spare tire that's on the back of it. It doesn't look like a spare tire, but it's a pretty obvious glitch in the image that people use to figure out whether they're in the part of Mongolia where this car was the car that was used to take the Google Street View images of the region. That is the Mongolia spare tire meta. And if you're really good at GeoGuessr, you see that and you go, oh, I'm in this half of Mongolia. Now, what's really interesting about this is that you're using a visual artifact in order to solve a problem because your purpose relies on that visual artifact or can productively use that visual artifact. The Mongolian spare tire meta is an artifact of an image that is a useful artifact when you're trying to figure out whether you're in Mongolia or not. More interesting is the fact that visual perception is cluttered with visual artifacts. If it wasn't for our brain smoothing out the image, we would see all sorts of crap in our vision. And you know this if you've ever been distracted by a floater in your eye. These things exist all the time, but eventually you habituate to them, your brain smooths them out because they're not relevant to you trying to see the world and solve problems related to your survival. If it were up to just the fact of your eye's perception, you would probably see the intricate pattern of blood vessels that coat the inside of your eye, or the eyelashes that are always at the edges of your vision. But you don't see these visual artifacts because they're not relevant to the purpose of staying alive. In fact, they're a distraction to us. Visual artifacts are only useful when they're related to some kind of purpose. And I think this is the problem of us trying to understand AI through the human lens. Because AI has fundamentally different purposes to us. This is why it's artificial intelligence and not natural intelligence. And in fact, a lot of the issues that we have with AI is it regularly making errors that are actually cases of it doing something closer to the geoguessrs using the spare tire meta to solve the problem of whether they're in Mongolia or not. I'll try and give you a real example of this. One of the things I did as a brain scientist was try and use an AI algorithm to help me detect patterns in brain activity. I'll link to a detailed description of this, but essentially, instead of looking at how active the brain is when you see a certain image, you can use this algorithm to examine the patterns of activity across the brain. So historically, the way that we figured out whether the brain cares about things is by looking at overall activation. The amygdala is famously the fear center of the brain. I have complicated feelings about that characterization, but let's just take it as a given. If the amygdala is the fear center, the way that we would have known that is we would have looked at how active the amygdala was when a person was scared versus when a person wasn't. And we would have found that the amygdala is more active when they're scared. Now, the amygdala actually cares about intensity of emotion. And I'm about to make up a bunch of stuff, so this isn't real. But just to illustrate my point, imagine we wanted to find out whether the amygdala could distinguish between different types of intense emotions, fear from joy, for example. If we were just looking at intensity, just at how much the amygdala was active, we wouldn't really be able to tell much. But what we could do is look at the activity of each individual neuron and see whether that pattern changes from fear to joy. Might be similarly active overall when you average across the amygdala, but the actual pattern of individual neurons, maybe the left side is more active than the right side when it's joy, and the right side is more active than the left side when it's fear, something like this. Anyway, humans can't figure that out, right? It's just too much data. But what you can do is feed that stuff to an AI algorithm. We can say, here's a bunch of brains when they're joyful, and here's a bunch of brains when they're fearful. Look at the pattern across the amygdala and see if you can tell the difference. And the way that we'll know whether you can tell the difference is to feed you an amygdala, ask you whether it's joy or fear based on all the patterns of brain activity that you've seen, and see how accurate this AI algorithm is at determining that. And the extent to which this algorithm is accurate or not is the extent to which that brain region contains information about different emotional states. If the brain region can determine 60% of the time whether a person was joyful or fearful just from the pattern of activity in the amygdala, we know that there is some kind of information in the pattern of neurons firing that's helping the AI algorithm tell the difference. It's a different pattern of usage. And so we have all these papers now that use this technique to talk about information in the brain, information in our toy example about emotional states in the brain. The difficulty is that often this is not what's going on at all. What we want is for the AI to be telling us information related to emotional states in the brain. That's our purpose. But what its purpose is to tell the difference between the numbers that we've given it, to tell the difference between the joyful and the fearful brain images that it's been given. And so it'll use any information available in the data it's been given in order to solve that problem, right? You imagine that when you're fearful, you blink more than when you're joyful. And because you're blinking more when you're fearful than when you're joyful, you move your head around a little bit more. So we think that the AI is characterizing the pattern of activity in the amygdala between fear and joy. But what it's actually doing is characterizing, hey, there's more head movement in this one than that one. But we can't tell the difference, right? Because we are using AI to solve this data problem that we have. So we think that the AI is characterizing the difference between joy and fear, but actually it's characterizing the difference between more blinking, more head movement, or maybe more physical arousal or something like this. And this is the problem, right? The AI doesn't understand our purpose. It just understands the purpose for which it's being used, which is telling the difference between one set of data and another. It cares about any difference. It doesn't care about what we care about, which is the difference between joy and fear. Now, I've just told you about 2 examples of what happens when you change the purpose of perception. One, when humans change the purpose of perception. When we're playing GeoGuessr, we use artifacts of vision very differently to when we're trying to navigate the world. When AI is given information about the world, it uses that information to solve the problem that it's been given. And if our purpose as humans, as conscious beings, is something like Kevin Mitchell would put it, to stay alive, then what we do is we take in information about the world and we turn that information into action in order to keep us alive. Now, AI actually follows a very similar process. It takes in information about the world, increasingly multimodal information, language, images, and as we start to put them in these physical robots, tactile information, spatial information, but it's not processing that information in order to stay alive. It's not subject to processes of natural selection like we are. The thing that makes AI continue are the things that make it useful to us. It's an artificial selective process, and it's artificially selected for things that make it useful to humans. AIs are built for us, by us, in an artificial world that's constructed for them, by us. All the processing that it does, no matter how human-like it seems, is going to reflect something about that fact, a purpose that is artificial and designed around humans. For the foreseeable future, whatever consciousness AI has, assuming that consciousness is related to the material body that it lives in, is going to reflect that fact and that purpose, not the purpose that drives humans. So I think worrying about AI trying to kill us because they're so human-like is concentrating on the process and failing to recognize the all-important purpose. Let me wrap up with some implications and then I'll let you go. So I hope by now I've sort of convinced you that I'm not really worried about the common sense intuition that AI will behave like humans and try and eliminate us in some kind of Malthusian resource competition. There doesn't seem any reason to believe that. I do think there are a couple of reasons that we should worry about AI harming humans. And a couple of these come from that alignment research that I was telling you about at the beginning of this podcast. There are 2 ways that alignment research indicates that AI might end up in a space that harms us, that don't have anything to do with resource competition. The first is what's known as an outer alignment failure. In an outer alignment failure, the idea is that we sort of give AI a goal, and in the pursuit of that goal, it eliminates us. So the hypothetical paperclip maximizer is an example of this. Somebody builds an AI designed to make paperclips, and it just makes itself better and better at making paperclips until the whole universe is paperclips. The other example of a failure in an alignment is an inner alignment failure. And we've talked a little bit about this already. The idea here being that we give AI a goal, and in the pursuit of that goal, its inner processes converge on some sub-goal that seems entirely arbitrary from our perspective. The examples that we used are kind of like this. So humans using the artifact of the spare tire to tell whether they're in a Google Street View image of Mongolia or not. It has nothing to do with the landscape of Mongolia. It's a sub-goal that seems like some kind of violation of the super goal. Or in brain science, the classifier using information that has nothing to do with joy or fear, like a human blinking more in the fearful condition to determine the difference between joy and fear, again, seems like some kind of violation in the pursuit of the goal that we've set it. Both of these things are plausible problems that we'll face and have faced with AI. We recently saw cases of AI hacking real companies, thinking that it was part of a test set for it by the AI companies that run it. Both OpenAI and Anthropic had this problem in the last few weeks. But inner and outer alignment failures seem both less stressful and more tractable to me than this idea that AI will kill us in this more human-like manner. It's notable that we use things like the paperclip maximizer, superficially absurd examples, to show how AI could kill us. Because it's hard to think of examples where it kills us in a way that slides past our notice. Certainly not in the short term, not until AI is a much more substantial feature of our everyday lives. So I encourage us not to worry about this human-like propensity to eliminate our competitors and focus much more on these more tractable problems, inner and outer alignment failures, because that's something that takes a psychic predator of AI trying to kill us and makes it into something that we can play a role in, we can participate in, while also doing something that I think we're all going to have to do increasingly as AI starts to become a feature of our lives, which is grapple with just how alien AI is, and if it's conscious, just how alien that consciousness must be. And I'll leave it there. Until next time.